All right, so these are notes. They're a little bit outside the book, but it's something that after talking with a couple of the other math teachers, we thought that it would be important. Finding the determinant of a matrix. So what is the determinant of a matrix? The determinant of a matrix is a special number that can be found from a matrix. The determinant is used to find the inverse of a matrix and can also be used to help solve systems of equations using matrices. So we're not going to go into any of the applications of determinants, which might feel like a big cop-out. I realize that we just don't have room for it in our curriculum, and it's not something that we really use in our curriculum that much. Now, the determinant of a matrix does become a huge part of future curriculum. I can remember my differential and linear equations class, my second semester of my freshman year of college. I was using matrices for probably half the class, and knowing how to define the determinant of every matrice was a huge part. It was an absolutely essential part of getting to my solutions. We're just not going to use that in this class. We're not going to actually use what the determinant is for, but we need to know how to find the determinant for the ACT. On the ACT, you will see this question. Again, it's like an imaginary number type thing. If you've taken 5 or 6 ACT practice tests, I guarantee you've seen a find the determinant of this matrix at least 2 or 3 times, if not more. It's one of those things where it's like, even though I can't guarantee that you'll get a determinant question on your ACT, I can guarantee that there's a high probability of getting a determinant question on your ACT. Normally, they give you the formula for a determinant on your ACT. It's almost always there. So technically speaking, you don't even need to learn it in class. I think ACT realizes a lot of math curriculums in high school are starting to cut it out, so they give you the formula, but at the same time, if you've practiced finding the determinant a little bit, that's one of those things that we've talked about in class. When the ACT is a test of minutes, every second you can save is a really, really important second to save. The symbol for determinant is basically the same thing as absolute value bar. So, for example, if matrix B is equal to some matrix, then when you put bars around the B, that means that you have the determinant of matrix B. All right, finding the determinant for a 2x2 matrix is really easy. I enjoy finding a determinant of a 2x2 matrix compared to a 3x3 because you multiply A times D and then you subtract B times C. So you multiply A times B and then you subtract B times C, and that's your determinant of matrix A. Really straightforward, really easy. We're going to go ahead and look at this example. So find the determinant of the following matrix. I'm going to multiply, let me use highlighter. I'm going to multiply the 1 and the 4. So I've got 1 times 4, and then I'm going to subtract the 3 and the 2. So this becomes 4 minus 6, and then I would say my determinant of matrix B is equal to -2. And that's my answer. So that's how you find the determinant of a matrix. Very straightforward for a 2x2 matrix. Finding the determinant of a 3x3 matrix is a little bit more complicated. So here you can see that I've got a 3x3 matrix, A, B, C, D, E, F, G, H, I, and you can see that there's a formula here. A times EI minus FH minus B times DI minus FG plus C times DH minus EG. Now, the easier way, and this is something that when I find determinants of 3x3 matrices, this is what I do. You have this column here. You take this number and then you multiply it by the determinant of the 2x2 matrix that's below it. So you're going to make a determinant of this matrix here. So you do A times that determinant. You have A times EI minus FH. You take that top number, multiply it by the leftover determinant, and you always start left to right. Then let me see if I can copy and paste this. Okay, I can only copy and paste my writing. Wonderful. So then I'm going to go ahead, I'm going to rewrite this matrix 2 times. So I have this matrix. A, B, C, D, E, F, G, H, I. All right, so now I'm going to look at my next row. I've got BEH. Well, now I'm going to take my determinant and I'm going to multiply by the determinant of the matrix that's left over in the bottom. I blocked out the row that B is in, and I'm going to multiply by that next matrix. So that's DI minus FG. And then finally, I've got this matrix one last time. A, B, C, D, E, F, G, H, I. I have my last column. Let me choose a better color, one I haven't used yet. I have this last column, and with that last column, I'm going to go ahead and multiply by the matrix that's left over. So I have the determinant of DH minus EG, but here I add this. This is a mistake I made a couple times, that I forgot that you add the third one to the determinant. So then I have C plus the determinant of that leftover matrix in the bottom, DH minus EG. That's a little trick that I do to help me memorize. That way I'm not just plugging things into the formula and always referencing back to the formula. You cover one column, and then you multiply the number of the top of the column by the determinant of the leftover matrix in the bottom row, in the bottom two rows. That might be more complicated for you to remember. Maybe just remembering the place and using this formula will help you out. But at the end of the day, I think covering the row and multiplying by the top number of that row by the determinant of the matrix left over is a little bit easier. All right, so we're going to find the determinant of the following matrix. Before we find the determinant of this matrix, I'm going to write it 2 more times. So that way, again, we can work on that skill of cover and use the leftover matrix for your determinant. All right, so we're going to go ahead. I'm going to cover up this first row. My top number is 6. Let me work backwards here. Let me actually use the top and go forward. I'm going to cover this first row. My top number is 6. So then I'm going to multiply 6 by the determinant of this leftover matrix in the bottom. So this is -2 times 7 minus 5 times 8. Wonderful. I subtract my next determinant. That's the next part of this formula, is you always subtract. I'm going to cover this middle row here. I'll keep using the same color. So I'm going to multiply by 1 because that's the top number of my determinant. I'm going to multiply by the determinant of the matrix in the bottom. So this becomes 4 times 7 minus 2 times 5. I'm going to go ahead and shrink this a little bit, make some space for myself. And then finally, I'm going to add the next part of my determinant. I'm going to cover this final row. The top number of that final row is also 1. I'm going to multiply by the determinant of my leftover number. So this becomes 1 times 4 times 8 minus 2 times -2. All right, so now I've plugged it into the formula. I've got all my numbers in the right spot. So now it's just a matter of doing order of operations. I have 6 times -14 minus 40 minus 1 times 28 minus 10 plus 1 times 32 plus 4. I get 6 times -54 minus 1 times 18 plus 1 times 36. I get -324 minus 18 plus 36, which will simplify down to -306. So the determinant of matrix D is equal to -306. Again, we're not doing anything with these determinants. We're not going to get there in this class. We're not going to actually use we're not going to go through the applications of determinants. We're just working on finding the determinants. So these are the only 2 things we're working with too, is we're only going to work with finding the determinant of a 2x2 matrix. We're going to work with finding the determinant of a 3x3 matrix. So now we have examples on both of those. The final thing that I have here is an example that you would see on an ACT. You can tell this is an ACT style question because it's multiple choice. You can see that the formula is given to you. Now this one's a little bit different. You're told what the determinant is equal to, and our goal is to solve for x. So we know that our determinant is going to be equal to 0, And we know that our determinant is going to be based on x plus 3 times x minus 2 minus 7 times 2 is going to be equal to 0. Right away, I can tell that this is a quadratic, so I'm going to have to set this up as a quadratic. X squared plus x minus 6 minus 14 is equal to 0, which becomes x squared plus x minus 20 is equal to 0. To solve for this quadratic, I will factor. This is x plus 5 times x minus 4 is equal to 0. We set each factor equal to 0. And we find that x is equal to negative 5 and x is equal to positive 4. So your answer here would be A. So a common ACT question, and I see these questions a lot on like determinant worksheets, I see them a lot on determinant homeworks in books, etc., is finding that determinant or finding a value when you're given the determinant knowing the rest of the matrix. So that's how to find the determinant. Again, we'll go over a couple examples in class as well, especially those 3x3s. I realize that can be a little bit complicated. 2x2s are easy. I think determinants of 2x2s are very, very easy. That's what you're going to need to know for your ACT. But if you want to move on to math, if you want to go on to engineering, especially like electrical engineering, computer engineering, you're going to be working a lot with matrices. So knowing how to figure out your determinants is a huge part of those futures. So any questions or concerns, please reach out as soon as possible and have a great night.